lesson, we're going to learn about arc length. Hopefully you remember what arc is, and perimeter of parts of circles. So it's still got to do with circles, except they may not be whole, okay? So the learning goal essentially gives it away, where the arc length is this formula. Now you will notice that this part is the circumference of a circle, and the reason for that is that arc is a part of a circle. Now, one thing that we need to learn to succeed is that theta, it's just this Greek letter, means angle. So it could be 30 degrees, 40 degrees, 50 degrees, whatever. And also recognize that perimeter is the whole of the outside of the shape, not just the arc. So we'll get into that very soon. So make sure you write the title, learning goal, success criteria, and off we go. All right, so we're going to find the arc length of the following. Now, what happens is that I need to draw this out. So we've got an arc here, and let's say we've got a thing here, and let's do this as 30 degrees, all right? So what I want to do is find the arc length of this guy here. So I need to get my formula from here, and the formula is length, and that means arc length, equals to theta over 360. So this is a fraction multiplied by our circumference of a circle, which is 2 pi r. All right. Now, one of the success criteria is that the theta is an angle. So what's our angle? One thing to give away the angle is that little thing there. So angle's 30. So in our calculator, we're going to go 30 over 360, and then we're going to multiply it by 2. Now, I know that in between the 2 and the pi and the r, there's times that mathematicians are too lazy to write, so I'm going to write them in myself. Pi is just a number. It exists on our calculator, so we're going to put that in. It's just calculator work. And r is our radius. Now, at the moment, I haven't put the radius, but I'm going to put it in here. And I'm going to say 5 meters is this length from here to here, okay? But all we're looking for is the length of this yellow bit that I'm highlighting. So I'm going to put 5 as the radius, and off we go. So I'm just going to pop this in my calculator. So I'm going to go 30 over 360 multiplied by 2 times pi times 5. And I get a number like this. Now, that looks like a really big number, so I'm going to do it to 2 decimal places. And my critical value is 7, and that's 5 or higher, so that means that 1 will turn into a 2. So I get the arc length will be 2.62, and our units are meters. All right, so that's that one there. For this one, I can see that it's 250 degrees, okay? So I'm going to have to do exactly the same thing, and once again, I've missed putting something down. So I'm going to put the radius here from the middle to the edge to be 10, let's say, kilometers. Let's get something really big. So this big circle. So I'm going to write my working out. So I'm going to go L equals theta over 360 times 2 pi r. Now, theta is just an angle. What's my angle? It's 250. So I'm going to pop that in over 360. Now I'm going to move across my fraction and go times. It's a different thing. And I know in between the 2 and the pi is a times. So I go 2 times pi. And my radius, I've just put it in, is 10. Okay. Now, all it is calculator work. You probably heard my calculator just slip out of my fingers for a bit. So 250 over 360 times 2 times pi, which is just a number in our calculator, times 10. And I get my arc length to be 43.7 6, 3, 3, 2, 3, 1, 3. And let's do it with the 2 decimal places as well. So I'm crossing it there. 3 is my critical value, and it's not more than 5, so this 3 will stay the same. So therefore, the arc length is 43.63, and our units are kilometres, and we'll just acknowledge that it's to 2 decimal places. Okay, so there are 2 examples of what arc length is. Let's find the perimeter of the following. Okay, so the first of all, what perimeter does, I'm going to go a bit quicker through this one, is that it just gives you the curvy bit. So I'm going to put this in yellow, all right? But perimeter is the whole of the circle. So it's the whole, not the whole of the circle, excuse me, it's the outside of the whole shape. So we're going to have to add on these pink bits as well, okay? Now, I can see this is not a full circle, it looks like 3/4 of a circle, and it actually is. This is a right angle here. So I'm going to first of all find the arc length of the circle, which is just going to be 3/4 of a circle. So I'm going to go 3/4. Now, in maths, of means times, so I'm going to go times the perimeter of the circle, which is just 2 pi r, okay? And now I'm just going to work that out by putting it in my calculator. 2 times pi times r. Now, what's my radius? Some of you have seen it already. It's this guy here. It's a 4 millimeters. So I'm going to go equals 3/4 times 2 times pi times 4. Now, all it is calculator work now. So times 2 times pi times our radius, which is just 4. And I get arc length is 18.84955592. Now, I'm not going to... This is not the answer because all I have found is the yellow bit, all right, the yellow highlighted bit, whilst the perimeter is the whole rest of the outside, which means that I have to add up this 4 here, and this will be 4 as well. So I'm going to have to add, so for perimeter, I'm going to have to, perimeter will equal the arc length, which I've got here, plus 4, plus another 4 here, all right? Sometimes these tend to be some of the trickiest concepts. So I'm going to add 4 and 4 to this, but that's not mathematically correct if I write it there, so I'm going to leave that empty. So I'm going to go plus 4, and the whole perimeter equals 26.84955592. Let's put it to 2 decimal places. That is certainly 5 or higher, so the 4 will change to a 5. So the perimeter equals, I'm going to put a line here, 26.85, and the units is millimeters, and it's to 2 decimal places. All right, I'm going to quickly do the semicircle. Now, the semicircle is what part of a circle? It is half of a circle, and remember, of means times. So I'm going to go times our perimeter of a circle, and I'm just going to pop everything in. Now, our radius is from the middle to the edge, so it's going to be half of this 10, which is 5. So times 5, and I'm going to pop that in our calculator. Half times 2 times pi times 5, and I get this big number here. So our arc length is 15.7079632.7. Now the perimeter, just like the other one, I'm going to make a division here, and I'll use a different colour. The perimeter will also be the arc length plus any straight lines, and in this case, this straight line. So all we've found with this is this. So with this, all we've found is this. Sometimes students struggle to understand that. So I need to add this bit on. I need to add that bit on, all right? Okay, so that bit is actually just 10. So I'm going to grab this number, add 10. And the whole perimeter, which is the whole of the outside, will be 25.707,963.27. And to 2 decimal places, that is certainly 5 or higher, so that 0 will go to a 1. So I've got perimeter equals 25.71. My units are meters, so I'm going to put meters, and I'm going to make note of it there. All right, that's it. Peace out.